This video is going to explain reference variables in C# through the use of an example that demonstrates what they are and what they are not. So here's our little example. We are intending to fill up an array with some random objects of this type vector. So vector is just a class that has been created that has an X, a Y, and a Z component. And so here we are going to try to fill up 9 vectors into an array, and through that demonstrate some of the differences between the way that beginning programmers expect objects in C# to behave and the way that they really do. So let's walk through this code and talk about what we expect. The output we plan to get is an array filled with each line filling a space in the array, and then the end result of writing out those 9 vectors. And you can see that the line a.x equals I, a.y equals 2 times I, and a.z is equal to 0 is what is building this pattern of 0, 0, 0, 1, 2, 0, 2, 4, 0. If we run this code on the left-hand side, what we get instead is this output, which is 9 copies of exactly the final result, 8, 16, 0. So let's walk through what is happening and what we're expecting to happen for this code. So if we look at it and we start at the very beginning and we use this vector A, that statement is declaring a vector, a variable named A, to be of type vector. It doesn't actually, it's not a vector yet, because as you know, when we work with classes and objects, we have to create instances of them. So the right-hand side of this is the new statement, which says, go create a new vector. What that does is over in memory somewhere, it creates a copy, a usable copy of the vector class. And then the equal sign actually connects the vector object A, which we now think of as a reference variable. It now refers to this location in memory that has been created through instantiation. And that link is sort of a old school, you would call this a pointer. So now if we look at the next line of code, the same thing happens when we create this array of objects of type vector, and we're going to name it vectors. So what we get is a reference variable called vectors, and it is going to point to an object that is an array of vectors. And the right-hand side actually allocates the memory and creates 9 spaces for vectors. Now, we go in and we go into our loop. So when I equals 0, this first line of our loop would assign our object A to be a.x is 0, a.y is 0, and a.z is 0. And then the next line of code where we say, oh, the ith element or the 0th element of the vector array should get a copy of A. And I say it that way because when we think of integers, this is exactly how it works. If I said vectors I equal I would expect the 0 element to take on the value 0, the 1 element to take on the value 1, etc. So in this case, I expect that this gets a copy of 0, 0, 0, and this is where our incorrect thinking begins. So I'm walking us through what our experience with vector arrays, arrays of integers or other base types, and how we think it should behave. And so if we go through the next loop, our A vector would take on the value of 1, 2, 0, and then when we do this line vectors bracket I equals A, we would expect that a copy of that 1, 2, 0 would go into our array. And if we just keep doing this through the whole set, we would end up with this array filled out as we are intending. Vector 1, vector 2, vector 3, vector 4, each one having its own value. The problem is that this is not the way that reference vectors work. This is the way that the built-in objects like int, byte, double would work. Those are usually value type variables, not reference type variables. All right, let's go through and explain what really happened in our current code to illustrate how reference variables work. And then later we'll fix up the code so that it actually produces the output that we're looking for. So let's start off with, we instantiate our vector A like before, which creates a reference variable named A that's going to point to objects of type vector, and create our XYZ vector space over in memory. Next, we again create our vector array by instantiating an array of vectors. So this is the same as our previous understanding. Now we're going to go in and we're going to set our first A value, a.x equal to I, a.y equal to 2 times I, and a.z equals z, 0. So that fills in our thing pointed to by A as 0, 0, 0. We then set vectors I, the 0th element of the array, to equal what A equals. And what this really means is we set vectors I to refer to the same thing that A refers to. So what we actually get on this line is a reference from stored in 0 over to this object. Next time through the loop, then, the value of A gets changed to 1, 2, 0. And this line, the vectors I line, runs again, and it creates another reference stored in location 1 to the exact same object. But that object's value is now 1, 2, 0 instead of 0, 0, 0. And then I do this again. It makes a link to the 240 copy, which is the same. And if I do that the whole time, what I end up with, 9 references to the single object pointed to by A. And at the time that the code finishes the first loop, the value of that single object is 8, 16, 0. So when I loop through the remaining values when I loop through the code again, writing out the values vector I, what it's doing is called dereferencing. So it dereferences vectors 0, and it gets this object. So it prints out 8, 16, 0. Then it dereferences object 1, and it points over here and gets 8, 16, 0 again. So our output is just repetitive copies, because what we did is this assignment in the yellow box just points to the same object reference. All right, so how do we fix this? Well, what we need to do is we need to move the vector A equals new vector inside the loop so that we get a new copy every time. So the first time through, we create our vectors on the first line of code here. We create our vector array. Then, first time into the loop, we create an A vector, and we assign it the value 0, 0, 0. And then we set vectors I equal to A. So the first time is this one gets linked to that object. Now, this for loop ends and begins again with the next iteration. Since vector A was created inside of this loop, the actual reference object, vector A, disappears. But this object over here in memory still has a vector, or a reference pointing to it. And so it is still attached and usable by referencing vectors 0. So the next time into this loop, we create another vector A object, and we set its value equal to 1, 2, 0. And then we run the vectors I line again, which attaches the second entry in the array to point to this object. And then when the array ends, vector A again disappears. So if we keep doing this, we are basically generating a new copy of A and then attaching it to the array. And when you do that all of the times, if you do that all 8 times, you end up with 8 copies or 9 copies of this object, 9 individual usable instances of the object vector, and 9 individual point reference variables pointing to those copies. So I can still access all of them. So when I loop through here, I am looping through and dereferencing each individual reference, and thus getting the output I expect. So hopefully that's helpful in explaining how reference variables can be a little confusing the first time you use them, because you're creating the reference variable on the left-hand side of a declaration statement. And then when you say equals, you're assigning it a location to point to, not specifically a value.